good evening. Today our group will be presenting about free and forced convection heat transfer. My name is Surendra Luis, and before we start, I will introduce to you my group members. This is
Nurul Atira, Tizalaya,
and this is
Afiq Faris bin Muhammad Syarat.
Now for the overview of our experiment. Convection is basically a conduction of heat in a streaming fluid, which is enhanced by convective transport. Convective transport means is the velocity with respect to the surface area. And since in convection, in forced convection, fluids are basically forced. So when they are forced, they have a potentially higher value, which shows that they are more efficient at heat transfer compared to natural convection. Now, in terms of mathematical equation, to do the analysis of forced convection, since they have many applications of forced convection, such as movement of fluid through tubes, pipes, and flat surfaces, there is a general equation which is called the Nusselt's number, equals to F multiplied by Prandtl's number, or Mach number, and Reynolds number. Heat transfer by simultaneous conduction and convection makes up the basis of industrial heat exchangers and its related equipment. For such cases, to predict and calculate the heat profiles, the heat transfer, we would be using the Hilton unit. The Hilton unit is a unit that we will show to you in a bit. In this unit, we will be studying the heat profiles, temperature profiles, and also heat flux in association with extended and flat surfaces. We'll use like 3 different types of surfaces, which are the flat surface, pin surface, and fin surface.
Okay, in this experiment, we have 2 objectives, which is to demonstrate the use of extended surface to improve heat transfer from the surface, and to determine the temperature distribution along an extended surface. Okay, for the theory of forced convection, the convection is classified in natural or free convection, and also the forced convection is depending on how the fluid motion is initiated. For natural convection, any fluid motion is caused by natural, such as affected by buoyancy. For forced convection, the fluid is forced to flow by the external device, such as pump and fan. Okay, this is free and forced convection heat transfer unit used for demonstrate of free and forced convection. Then to determination of free and forced convection heat transfer to the air from vertical flat plate, then cylindrical surface, and tempered fins. Okay, here we have the heater power control, which is show the watts, then the thermometer to show the temperature, and fan speed, the main supply. Okay. For this unit, at the top of this unit, we have a fan. Then here we have the whole of airflow to ensure there is airflow from the bottom to top. Okay, here we have heated bed test box, which is all the plates attached here. Okay, then we have temperature probe and anemometer, which is to check the velocity of air and temperature.
Using our free and forced convection heat transfer unit, we will be conducting an experiment to demonstrate the use of extended surface in improving the rate of heat transfer from surface. So to start off the experiment, our first step in this procedure is to attach the flat surface to the towel. Next, we will have to attach the heat supply, and we have to attach the thermometer cable, which is to record the temperature. The next step is to get our record of ambient air temperature. So, we are about to start. We'll have to on the power supply, and we have to turn the heater supply to 80 watts. Once it has been turned to 80 watts, we will have to wait for the thermometer to show 75 degrees. Once it has reached 75 degrees, we will have to turn down the heater power to 20 watts. Once changed to 20 watts, we will have to wait for a few minutes until the temperature gives a steady reading. So once it has given a steady reading, we record down the reading of the temperature. And then now we change the airspeed to 1.0 meters per second. The previous reading was at 0.0 meters per second. The airspeed can be read using the anemometer, which is connected to the fan. So now once it has been changed, we will have to wait until it shows again a stable reading for the temperature, and we record it again once more. And now for next step is to change the airspeed, increase it to 1.5 meters per second. And we wait again for a few minutes until we have a steady reading, and we record the reading. And that is the end of our first part of our experiment. For second and third part of experiment, we will conduct the same procedure, the same steps, but using a different surface. The type of surface that we will be using is the pin surface, and the fin surface. We will be conducting the same experiment using the three different air supply speeds, which are 0.0 meters per second, 1.0 meters per second, and 1.5 meters per second.
After we go through the experiment, and after it is finished, we are going through the shutdown procedure, where we are going to shut down this unit properly without damaging it. Okay, firstly, we need to make sure that all the probe, all the control mechanism there are set to 0. and then shut down all the power supply there. Next, we are going to disengage the plate from this unit. Okay, to ensure the safety, make sure that you use gloves or any protection, because this at this particular area it is very hot. But if you don't have, just wait for a few moments and let it cool down for a few minutes. After it's cooled down, disconnect all the supply. And keep it at where it should be kept. After all the connectors from the main supply or any power have been isolated from the unit, then we can wrap it with the plastics provided to make sure that there is no harm done to the unit. Okay, after it is safe, and we can dismiss from the lab. As we know, the unit are in the safe mode. Next, in the discussion and conclusion part, we are going to discuss about the variables that are present in this experiment, which is the air velocity, the heater temperature, the difference between the heater temperature and the ambient temperature. Okay, the air velocity present as a difference variable, which is we can change the variable using the fan and using the machine. And the heater temperature, which is where the what the temperature that we get after the plates is heated, and after it has been applied to the air velocity after a few minutes, and then the temperature of the heater is being subtracted with the ambient temperature that is present in the particular places. Okay, for the conclusion, we can say theoretically we can say that the velocity of the air and the surface temperature for each plate are related. How does it related? Is as the higher the velocity of air created by the fan, the lower the surface temperature of every plate. Here, should be the highest temperature is the highest temperature that should be recorded is at the flat plate, and the lowest temperature that we should get is at the fin plate, and the pin plate should get the to get the value in between flat and pin. And next, the relation between the total surfaces of the plates and the surface temperature of each plate. Okay, we can say that the total surface of plates affected the surface temperature, as the higher the total surface area of the plate, then the lower the surface temperature for each plate. Why? Because the higher the total surface, the larger the surface of heat transfer between the area itself. Thus, we can say that as the air velocity increase, the surface temperature of every plate decreases. Okay, that's all from me. Thank you.